Good morning, everyone. Welcome to our online teaching class. And our subject for today is and now we are still in Unit 5, which is home electricity. Okay, before we go to our topic, let's read three vocabulary words. Everybody, can you turn on your microphone and let us read? Nature.
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 Very good. Can you spell the word nature? N-A.
Nature. Nature.
Very good. Nature in Thai.
ธรรมชาติ
Again.
ธรรมชาติ
Good. Next one. Everybody, can you open your microphone? Third one, source.
ผมรู้จักวัคซีน
Source.
โดย
Okay,
เอง
wait a minute. Someone is coming.
Okay.
Okay, it's late again. Why? Okay, everybody, turn on your microphone. Source.
source
Everybody, spell the word source. S-O.
source is
S O U R
SOURCE
In Thai.
แหล่งที่มา
Very good. Next one. Everybody read. Spin.
spin
Everybody spell the word spin. S-P.
spin
In Thai.
ปั่น
Very good. Okay. Everybody read. Nature.
nature
Next, source.
source แหล่งที่มา
Spin.
spin
In Thai.
ปั่น
Okay, now let's go to our topic. Our topic for today is all about electricity from nature. Okay, there are different types of electricity from nature that where can we get the electricity. Okay, not only burning coals, okay, not only that you're going to use water or dam, there are many, okay, from the nature. We can get electricity through the mains and batteries. So this is the main. This one is what they call plug, and this one's what they called what? What do you call this one? What do you call this one? Start with the S.
socket
Very good. Socket. And this one, what do you call this one? It's
battery
batteries. Very good. So we can get electricity here. Apart from the mains and batteries, we can also get electricity from nature. Do you know nature? Oh, again, nature in Thai. Oh, what's nature in Thai? Or what
ธรรม
called
ชา
the
ติ
very good, or what called environment. Nature, it means the natural materials. Okay, natural materials like mountain, sea, sky. Okay, those are the natural materials. So what I call nature. Even air, it's part of our nature. Next one. There are many materials from nature that can be used producing electricity. For example, what's this?
สั้น
Very good. The sun. Okay, another one. What's that?
water
Water. And this one?
wind
Wind. So these are the materials that we're going to use, people use when they are going to produce electricity. How? How they can they produce electricity? By the use of the sun, the water, and the wind. Okay? So the sun is the biggest source of energy. So this one. For example, this one's what they call the solar energy. So the people, they are going to use the solar panel, they are going to use the sunlight, okay? Because the sunlight's very hot, right? And this energy comes from the heat and light coming from the sun, okay? This one. This one's what we call solar energy or solar panel. For example, okay? I'm going to show you a video first, but I'm going solar panel. So this one, solar panel. Solar panel homes. For example, in our home. I don't know if some of you, do you have this one in your home? This one? Do you have?
He
Or
don't
ha
have.
or
Teacher, I don't have.
okay,
Don't have.
because for example, my brother in the Philippines, okay, he has like this a solar panel
Mà đừng
because
ở cái khe bán tiêu
okay,
lửa phủ
in the
nữa.
Philippines, my brother he has this one. Why? Because every month he pays the electricity bill is so expensive. For example, my brother, okay, pay the electricity for 20,000 baht, okay, without solar panel. And now my brother installed like this, okay, he bought the solar panel and he pays only 5,000 baht, okay, 5,000 baht every month. See how much money he saved, okay, when you're going to use like this one.
Yes.
So I'm going to show you a video
Save
first.
for money.
Oh, so
Solar panel energy. Okay, so let's watch first. Can you hear?
Hi, I'm Lee Patrick Sullivan with Energy Now, and today I'd like to talk to you about the power of the sun. Solar power is the most abundant, most renewable resource we have. If we could collect 1/100th of 1% of the sun's energy reaching the Earth, it would be more energy than all humans use today. Just outside Yuma, Arizona is the sunniest place in the world. 90% of the year, the skies are clear. And these southwest deserts have enough suitable land to supply 80% of the entire planet's current use. The sun has produced energy for billions of years and naturally energizes all of the plants on the planet. These plants give energy to animals and power the
Ah,
human body. This is done by a process called photosynthesis. For decades now, scientists have unlocked the secrets of how a plant creates energy through photosynthesis and can duplicate that process using modern technology and silicone. This process of creating electricity from the sun can power our homes and cities. There are two ways of capturing the power of the sun. First is photovoltaic devices, more commonly known as solar cells. They change sunlight directly into electricity. These individual cells are joined together to make solar panels. These can be placed on rooftops, in calculators, and even on large scale fields covering many acres to power cities. Solar energy systems produce no air pollutants or carbon dioxide. And because they can be placed on the top of existing buildings, they do not require extra land for power plants. Another way to capture the sun's energy is by capturing its heat. Solar thermal electric power plants generate electricity by concentrating solar energy to boil water, which then produces steam. This steam turns a turbine, which moves a generator to produce electricity. Solar thermal electric plants consist of fields of mirrors to reflect the concentrated sunlight onto a receiver. The receiver then collects this solar energy and converts it to heat. The production of energy from solar thermal plants work essentially the same as fossil fuel power plants. But instead of producing steam from burning fossil fuels, the steam is made by the sun. The only downside to this source of technology is that the power only exists as long as the sun is up. To help solve this problem, other forms of solar technology have been explored. Scientists are currently working on methods to store this energy for cloudy days and nighttime. One way to conquer this problem is building new power plants that combine a multitude of renewable energy sources. Using solar power and wind power and biogas could do this. When one method is not creating electricity, the other could take over. Other methods, such as storing excess power in batteries, could also be a possible future for solar technology.
it's finished already. So that's what they call the solar. Sorry, wait. That's the solar panel. or solar energy. It means when we say solar energy, wait,
Here's a question for you.
when we say solar energy, it means we use the sunlight to get the energy from the sun. Okay, sorry. So this one. And now the wind always blow. It can be used to. Okay, wait a moment. There's a small internet. Okay, the wind always blow. It can be used in producing electricity too. Okay, for example, this one's the wind turbine. Okay, and the wind always. Okay, this one is called wind energy. Is the energy which is produced by the blowing wind. Have you seen this one? Do you have this one here in Thailand? Wind energy? Because in the Philippines
Yes.
there are many. Okay, so this one they are going to use the wind energy. When the solar panel, okay, we use the sunlight, right? And another one, this one, wind energy, wind turbine, okay, you use the wind. Okay, for example, I'm going to show a video again. Who's this? Who's this? Okay, I'm going to show you a video. Okay, tap and the wind turbines. This one.
Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity uses each day. And unlike
Oh, yeah.
coal or oil, this resource is totally renewed each day. So how can we harness this incredible amount of energy? And is it possible to create a world powered entirely by wind? The basic principle of wind energy is simple. A series of sails or blades mounted around a rotor catch the wind and translate its kinetic energy into rotational energy. Traditional windmills use that rotational energy to grind wheat or pump water. But in modern wind turbines, it turns a generator that creates electricity. This conversion from wind to rotational energy to electricity has defined wind turbines since their invention in the late 19th century. And there are three primary factors that determine just how much energy they can produce: the size and orientation of the blades aerodynamic design, and the amount of wind turning the rotor. First up, blade orientation. Wind turbines can be designed with their rotor on a vertical axis or a horizontal axis. Vertical blades can pick up wind coming from any direction, but with much less efficiency than horizontal axis rotors. Horizontal designs allow blades to capture the wind's full force by tracking the wind's direction and turning to face it. This turning process is called yawing, and older windmills achieved it through manual monitoring. Today, wind sensors and computer systems automatically adjust the blades with expert precision to capture as much energy as possible. Outside rotor orientation, the blades themselves need to be shaped to maximize efficiency. While early designs used flat blades, modern blades are curved like airplane wings. Wind travels faster over the curved surface, creating a low-pressure pocket above the blade that forces it upwards. Since the amount of lift depends on the angle at which the wind is moving relative to the blade, modern blades also incorporate a twist, optimizing how much of the blade can cut into the wind. Made of fiberglass and resin layers, these blades are strong enough to operate through rain, lightning, and blistering sunlight for over 20 years. Even with aerodynamic blades and a horizontal rotor, a wind turbine can only capture wind if it's in a windy environment. Wind speeds typically increase the higher into the atmosphere you travel. So today, most turbines are well over 100 meters tall, with equally large rotor diameters. A turbine of this height and size can capture a huge amount of wind, generating enough electricity every year to power 750 American homes. A wind farm of 200 similarly sized turbines could power over 150,000 American homes, or twice as many European homes, for an entire year. Offshore wind farms contain an even greater number of even larger turbines. In 2019, the largest wind turbine ever built began operating off the coast of the Netherlands. With a rotor diameter of 220 meters, just one of these turbines can meet the annual power needs of 16,000 European households. Despite its amazing potential, wind energy still faces challenges. Wind may be a free and unlimited fuel, but no matter how large or efficient a turbine is, there's a mathematical limit to how much wind it can convert into electricity. German physicist Albert Betz calculated that since some wind must remain to keep the blades spinning, a turbine can only ever capture 59.3% of the wind's energy. Additionally, some people feel turbines disrupt natural scenery, and wind energy's intermittent availability can make it difficult to integrate into electrical grids. But even with these challenges, modern wind turbines have made wind energy the most efficient and inexpensive source of electricity. Wind turbines already provide essential energy for communities around the world, and for many farmers, hosting a wind turbine can be a reliable source of additional income. With continued improvements in wind forecasting, electrical grid infrastructure, and energy storage, wind power might blow away all our energy problems. Next.
Okay, so wait. That is the wind energy, right? What's the number one? The power station that we use? Oh, yes, very good. Solar. Okay, very good. That's solar. And number two that we use?
Is
Wind.
power.
Okay, it's wind
Wind
energy. Okay,
Energy.
very good. You remember because later we're going to play quizzes. Okay.
Teacher, I have wind energy. Teacher, this.
Where's it? Oh
Okay.
yes. Okay.
I
Wind
have to,
energy.
sir.
Okay. Next one. Another one, water can be used in producing electricity as well. So this one's what they call dam. What they call hydroelectric power. So energy is produced using what? Using water. Okay, so let's watch again this video and I'm going to show to you. So is the sunlight, another one, the wind energy, and this one is the hydroelectric power, which is okay the use of dam or the rain. Okay, so can you see now,
Hydropower.
students?
Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
So hydroelectric power, it's used, you can get electricity through the use of water. Okay, and now let's play game. Okay, wait a moment. So the number one, it's the solar panel or solar energy. After solar energy, it's the wind energy. After the wind energy, it's the hydroelectric energy. Okay, and now I'm going to play this game. Word wall activity. Okay, can you see?
Yeah.
Okay. So what's this? Solar energy, wind energy, hydroelectric energy. What's this? Solar
Solar
energy, hydroelectric. What?
Solar.
Solar. Very good. How about this one?
What is that wind?
Wind. Very good. I have only one student.
A
How
wind.
about this one?
Hydroelectric.
Hydroelectric. Very good. How about this one?
A wind.
Wind.
Wind. Very good. How about this one?
Energy.
Solar energy.
Very good. How about this one?
energy.
Hydro
Hydroelectric.
Hydroelectric energy. This one?
Energy.
hydroelectric energy.
Hydroelectric. And this one?
Wind
Wind energy.
energy.
Solar energy.
And submit answer. Very good. You understand. Okay, and now let's go to our quiz activity.
Oh, I
So
like it.
first, we're going to review first. Okay, review. Can you see now? Can you see?
Yes,
Yes.
Okay, it's better now. Okay, sorry.
Padi papa, padi
Oh.
padi.
Oh, Supakrit, if I'm going to call your name 3 times, I'm going to remove you in this meeting. Okay, understand? If I call your name 3 times, I'm going to remove you because you're talking and talk and talk. Okay, we can get electricity from two of the following. Which one? A, B, C, D. Which one? Wind energy and what? So you're going to click these two, right?
Energy and wind energy.
Okay, very good. So you're going to click those two. Next one. Sorry. Number 2. Electricity that comes from the power station is called what? Mains, battery, main, or
Main.
reel?
Main. The main.
Mains. Very good. Next, number 3. This generates electricity with blank.
Energy.
Again, wind energy. Very good. Next, solar energy is converted to electricity using one of these. A, B, C, or D? Huh?
C.
C. Very good. Next, number 5. All of this means use electricity except one? A,
Uh,
B,
A,
C, D.
C,
Huh?
A, C, A, B,
All of this use means electricity except. So it means one
A,
of this
B,
picture.
C,
Are you sure? C?
yes,
A?
A,
Wrong. The correct answer is letter A.
yeah.
Sorry, letter D. The clock.
Oh, exit, picture exit. Everything
Next one. Select of sources of electricity. Which one? So of course, you're going to select all,
Oh,
right?
Oh my god.
yes.
Next one. One object that contains chemical energy which can be converted to electrical energy. Which one? A, B, C, D.
A, B, C,
Which one?
D, Mega.
Okay, very good. The correct answer is letter D because they use chemical here to make battery, right? Next. We can get electricity from the power station and from,
Batteries.
okay, let us see, battery. Very good. And number 9, other sources of electricity different from mains are called alternative, best, experimental, or final test. The correct answer here is alternative. It means, as I said, okay, there are many types of power station. Okay, you're going to use the sunlight. Okay, you're going to use the wind, the water. Okay, it's alternative. Okay, next one. One of these bring electricity from the power station to our
C.
homes. A, B, or C, D. What?
C.
Very good. This one, C. It's what we call the power lines. Okay, and now let's start the quiz
Let's
game.
play.
Classic.
Classic. Yeah, I want
And
classic.
continue. And I'm going to send the link to you. And those students who didn't join, I'm going to mark them absent. So it means they are not participating. Go.
Apa ya? Lihat nih kalau Anda. Methanol on. Salah. Pemicuan pada konsum secara on sedikit sehingga bisa tergabung di sana.
Okay, let's start now.
Number 2, saya high
Fortune students.
one in your world and go instruments but it's my
Chisa.
a portion of the program. Oh, ini I chose it of what
At Chisa and Team Chaya, are you using only one account? No. Okay. What's only one? Okay, let us check the attendance. Those students who are not here, going to mark them absent. Supakrit, are you here? Okay.
Not here, Canada.
A Kit, not here.
I not see Canada.
Who else? Can you help me?
Canada.
Huh? What's the name?
Not I cannot see.
Okay, even Pacharapol. Pacharapol, it's here. Okay. Who else? And Uratrada. Where is she? Oh, see? They are not here.
Canada choice.
Tekchasit, also not here. Right? Okay, let's mark them absent. So it means they open their camera. They are not opening their camera.
Penyepat choice.
Okay? So it means they are not listening. Pacharapol not there, right? Or absent. Pacharapol.
Ulalada choice.
So it means if you're not going to join, it means you're not listening. Pacharapol, it's there already. Who else? Okay, let's make it 75. Sorry. 100%. So Who is absent? How many students here? 826. 26.
25.
Okay, 25. Say 25. Okay. 25.
But we have 20
24.
only.
No, 24. Because Pachisa and Team Chaya, they are only one. So here now, how many? 21.
21.
Who didn't come? Let's check.
Oh God. Take
Tek Chasit, no? Okay, Tek Chasit.
Still you count it.
Only Tek Chasit. And who?
Ah.
Teacher, I can open link.
Oh no, you cannot open the link? Are you sure?
Can eat.
Not him.
Oh, this one, I send it to her again.
Hindi kaya na. Hindi pala.
Who else?
Ah. Okay.
Okay, let's start now. We don't have enough time.
Not him.
Okay, kanya ko number 1. Number 2, Bitira. Number 2, Ayan pa number 2.
Teacher, I cannot play.
It's okay. Take a seat. Number 1, a bit. Number 1. Happy with number 1. What's your opponent, Chunky Chan? You cannot know where you're playing.
I cannot play.
Wow. What?
Five, four, three, two, one. Let's enter now because we don't have enough time. Okay, so the R number 3 is appropriate. Number 2 in the first place is happy with. Okay, and now let's go to our live worksheet activity. Okay, don't forget to write your name, your grade, and your student number. Okay, I'm going to send the link now and connect the speakers. Okay. This one, the link. Okay.